Hello my dear colleagues, this is Gustavo Pinto and this is my great pleasure to talk to you about this work named What is the Vocabulary of Flaky Tests? And this is a joint work with Breno Miranda, Supun Dissanayake, Marcelo Christoph Treude and Antonia Bertolino. So the first question that you may be asking is, what is a flaky test? So for a moment, consider the code snippet here that you can see on this screen. As you can see, there is this ordinary Java class, and inside this class you have this test method. So what if I tell you that today, if you run this test, the test would be passing, the test is green. So everything is fine, so everything is good. What if I tell you that if you run the same test in another moment, like tomorrow, without doing any modification to the source code or to the environment, the outcome of the test could be actually different? This is the behavior, this is the idea of flaky test. So flaky test is a test that has this non-deterministic behavior. You run the test, sometimes it's passing, sometimes not passing, and also sometimes you may not even know the reason why the testing is not passing anymore. So now let's take a look a little bit closer in this test code here to see what the test is doing. As you can see here, there is these lines here where we are creating an encoder and we are writing something to that encoder, and after that we are also creating a buffer and we are also again writing something to that encoder, and finally we are flushing something to that buffer on a given channel, and eventually we are also doing a dump in that channel. So very briefly speaking, we are doing some I/O computations, I/O operations over this test case here. So the same exercise some researchers did in the past. So for instance, there is a couple of empirical based studies in which the authors manually investigated hundreds or even thousands of flaky tests to see what are the design decisions or the programming language constructs that these flaky tests use. There is also some kind of work in which the authors propose dynamically techniques to automatically identify if a given test is flaky or not. However, what we think is missing is some kind of tools or techniques that could statically identify if a given test is flaky or not. So the $1 million question is how to statically detect if a given test code is flaky or not. So to answer this research question, we followed a 5-steps approach, and in the first step we actually try to identify the flaky test, the flaky data, and after we have this set of flaky tests, we employed some tokenization procedures, and in this tokenization process we try to extract the features or the source code identifiers that are the most interesting from this test data, and we use these features as inputs to machine learning algorithms, and the output of the machine learning is actually a rank with the features that have the best performance in the machine learning algorithms. And the final result, the ultimate contribution of this paper is actually a list of words, of features that we believe are strongly related to flakiness. So the first process here is try to identify flaky data, flaky test. So how do you know that if a given test is flaky or not? If we go back to this example here, very common solution would be to run this test again. So if you run, okay, it's passing, but then we decided to run this test 10 times. 10 times is not enough to find data. We shortly noticed that. So then we moved it to 100 executions. And okay, after 100 executions, we noticed that this test is not passing here and not passing there. So this was the empirical based threshold that we found to decide to infer if a given test code is flaky or not. So after that, the idea is to scale up these to other projects, and we started by selecting 24 projects, and these projects, they were studied in another study related to flakiness. We used the same list of projects, and we had to extract the test data, the test code from these projects. And after this process, we ended up with 64,000 test files, and we had to run these test files 100 of times, which ended up with 60.4 million executions. And after performing all these executions, we noticed that there are actually some flaky data here and flaky data there. And what we did after that was try to isolate these flaky tests from the others and try to understand a little bit more about what of these flaky tests are doing. So after we identified a flaky test, the next step is to understand what the test is doing and try to extract the features over these flaky tests. So the idea here is to employ some tokenization procedures, and we started by removing some Java keywords. For instance, we removed the public, the class keywords, and after that we also removed the dots, we removed the semicolon, we removed the equals and other identifiers. And after that we split the words using the camel case syntax. So we created more features using this approach, and after using that we also put all the words to lowercase, and after removing some duplications we ended up with this set of features or set of source code identifiers. And again, we used these source code identifiers as the inputs for the machine learning algorithm. And in case of the machine learning algorithms, we used 5 well-known machine learning algorithms, and they are implemented on Weka. We just took advantage of that, and all the code, all the data, everything that we produced on this research is made available on this website, and we are more than happy to help others to reuse our data in case if you want, just let us know. And after creating all this data and after all this process, we were able to answer 4 research questions, and the first one is how prevalent are flaky tests? But before answering this research question, let's just move one step back and remember that we were studying some open source projects, and then we extract test data and we run this test data 100 times to eventually find some flaky tests. And what we found is actually there are flaky tests in 25% of the studied projects, and overall we found 86 flaky tests over our data set, and this actor project is actually the project that has the highest number of flaky tests. Another interesting observation comes from this figure here, and as you can see, the majority of the tests are passing the majority of the time. So the flaky behavior does not appear really frequently. The second research question is how accurately could we predict test flakiness? And to answer this research question, we used the 5 machine learning algorithms, and we use it as input to these algorithms the features that we extract from the Flaky data, from the Flaky test. And what we can see from this table here is that the random forest is the machine learning algorithm that performed the best, and support vector machine was also really good in terms of performance. In this research question, we also did some manipulations over the configurations of these machine learning algorithms, but we noticed that the default configuration was actually the one that achieved the best performance. Then next, the third research question is what value do different features add to the classifier? And in this case, feature is part of the tokenization process. So for instance, if we are keeping or not using the stop words, or if we are using or not the Java keywords, or if we are putting the words to lowercase or not. So we measure with all these features, and we also measure with considering all the features altogether. And what we notice is that when we are using all the features altogether is when we have the best performance. And this is for random forest, but this is also the same for the second best machine learning algorithm, which is support vector machine. So in this case, there is no much impact on using these different features on these classifiers. So in this final research question, we asked which are the test code identifiers more strongly related to test flakiness. And this table summarizes the findings, and as we can see, features such as job, table, ID, action are the ones that have the highest information gain. But overall, what we notice is that features that are related to remote tasks are the ones that appears the most in this table here, such as XML, such as workflow, JPA, among many others. So to conclude in this paper, we study 24 open source projects and we extract test data from them, and we did 6 million executions over these test data, and eventually we used the tokenization features that we extracted from these Flaky tests to feed machine learning classifiers. And with that, we were able to answer 4 research questions, including how prevalent are Flaky tests, if we could predict flakiness, what is the value of the different features, and finally, what is the vocabulary of Flaky tests. With this, I conclude this talk, and I will be more than happy to take your questions. Thank you.